Let's solve this trigonometric equation. Now, I've got two trig expressions and a regular number, and I can't just combine these two sine terms and say that I've got two of them, because if you look closely at their interiors, they are slightly different. One has a plus sign and one has a minus sign. So how am I going to deal with this? Well, if you remember, when we did identities, we had a formula for when we had the sign of things added or the sign of things that are subtracted. So you need to go find that formula and we'll apply it in this instance. So the sign of x plus pi fourths is going to be, once the formula is applied, the sine of x times the cosine of pi fourths plus the cosine of x times the sine of pi fourths. Now, that just accounts for that first expression. I still need to apply a formula to the second expression. So the formula for sine of two things that are subtracted is going to net us sine of x times the cosine of pi fourths minus the cosine of x times the sine of pi fourths. And of course, this is all still equal to -1. Now, look at the things that are colored versus the items that are in purple. The items that are in purple, you know an exact value for by finding it on the unit circle. So let's go ahead and evaluate what we can. The cosine of pi fourths is the square root of 2 divided by 2. The sine of pi fourths is the same. And I've got these values. Now, because I have the same values twice, I have cosine of x times the square root of 2 divided by 2 minus cosine of x divided by this, or times the square root of 2 divided by 2. These two items can cancel out, and I'm left with 2 square roots of 2 divided by 2 times sine of x, and it's all still equal to -1. This looks a lot better than what I started with, because I've gotten it down to where I just have one trigonometric expression and one variable inside of it. Now 2's are going to cancel, leaving me with the square root of 2 times the sine of x equals -1, and I can divide by the square root of 2 to say that the sine of x equals -1 divided by the square root of 2. If I rationalize this to make it look more familiar, the sine of x equals negative square root of 2 divided by 2. So I ask myself, where on the unit circle is the sine of x equal to the negative square root of 2 divided by 2? The answers are at 5 pi fourths and at 7 pi fourths. And in both instances, to get my general solution, I've added 2k pi to each of these expressions. So, this wasn't really any harder than solving a basic equation. We just had to apply a formula. After that, it was a matter of evaluating what we knew and algebraically simplifying the expression until we were back to just looking for an angle on the unit circle.